Thanks, everyone. And again, today we're going to be talking about building a full stack application using Go, Couchbase, and Angular 2. And we're going to continue with last week's theme of getting heavily into TypeScript and Angular 2. And we're not going to spend too much time on slideware. So we're going to dive right in. And I've got some really good feedback so far in doing these. And some of the things that folks have been asking for is to run through how the environment's set up again. There's been a lot of questions on that, and specifically how the Go environment is set up on my local machine, and also how Couchbase is set up running Docker. And we'll go ahead and run through that, and again continue on. We'll walk through some code examples using TypeScript and using my new favorite editor, Atom, and let's get started. So first thing I want to do is just show how my particular Go environment is set up. So from the command line, if you do Go and version, we'll see that I'm running 153. Reason for that is 1.6, a lot newer. Garbage collection is completely different, I believe, in 1.6. I might be wrong. I can look that up later, but I know there's some pretty heavy changes between 1.5 and 1.6, so for the sake of this webinar series, we decided to just continue using 1.5. And other thing I want to look at is how my environment variables are set up and what's important on that. So if I do env and basically grep go, we'll see the two things that are really important here in my path. We'll see that I've got go user local go bin, which is where I've got Go installed. And then also what's really important is the Go path. In order to get anything to run properly and be able to make use of Go's very opinionated and very cool paths for using source and being able to grab those and consume those within your application, you need to have your Go path set up. And so if we actually go and take a look at what my Go path looks like, and take a look at this, and so take a look here. We'll see that we've basically got bin, package, and source. And what's interesting here is source, which is where everything that we're going to be talking about today. So if I go source ls, we'll see that we have github.com, golang.org, which are packages that I'm using from, and then 9fans.net. So these are packages and they're source repos of where I'm grabbing those from. So let's go to GitHub, and we'll take a look at, these are all the packages that I consume within my various applications that utilize my Go source repo. So Couchbase Labs, Golang, NSF, etc. You'll see these all listed out here. And if we go to Couchbase Labs, and we'll see within here, comply Golang. There's some other things that I've been building here with Go that we've got hosted within Couchbase Labs, but the one that in particular is the comply application that we're talking about today. So let's go over and take a look. And if we look at this now, you'll see that there's this maps very nicely to what we have defined in our Go path, and then you'll see this very opinionated and very common pathway that you'll see from where our Go path is all the way down to our source. And this is very useful, and it's very repeatable as you're building applications in Go, that you see once you have your path set up and you sort of understand what that's doing under the covers and how you consume these different repositories, it's really easy to do that from using this very standard Go format. So next thing we want to do is we want to verify that we have Couchbase running, and for this we're going to use Docker. And again, the command that I use for that is listed here. But before I do that, I want to check one thing. Since I am on a Mac, I have to use Docker machine to consume Docker, which sets up an image using VirtualBox that allows us to then, from that VirtualBox image, use Docker containers within it. So if I take a look and make sure that Docker machine is running, whoops, wrong command there. still the wrong command. There we go. So we'll see that we have the VirtualBox image running, and there's the IP that I'm going to be using. This is the port specifically that we would connect to be able to do anything specific to Docker or using Docker machine. So then if I actually run the Docker command and do Docker ps, see we have nothing running. So I'm going to go ahead and start up a Couchbase instance, and this is the developer preview of Couchbase 4.5, and I'll go ahead and run that. And pretty simple. We'll see that it's up. If I do Docker s, we'll see that it's there, and it's based on that name that I gave it and all of the ports that I opened up and assigned to be able to consume those and how I've mapped them. You'll see that it's listed there. So then the next thing I want to do is open up my browser and configure Couchbase. And we can do this really quickly. We'll go ahead and open Safari up here. Make that a little easier to see. And we'll go to so from within here, we're just going to set up a new instance. Again, we've been through this before, but we'll walk through it really quickly again. Don't need full text on here. For this, I'll use 1024, and I don't need to configure anything for full text. I'll use global index for now. I'm going to start a new cluster, click next. Don't need any sample buckets, click next again. For a default bucket, don't need a replica for that. We'll click enable to be able to flush it and move forward. Don't want no updates on this. I agree to the terms. Administrator, put in password and password. And we'll see that we're up and running. So next thing I want to do is for the data bucket that I have, I don't need this bucket, so I'm going to go ahead and delete it. And I'll go ahead and create a new data bucket. And our application is looking for a bucket that we refer to as the name comply. So I'll just do that. I'll leave all of these standard. I don't need replicas since this is on a single node cluster. And I'll just make sure that I enable flush. Flush is great. Again, if you're new to Couchbase, flush allows you to do unit testing really quickly and simply because you can delete all of the documents within a database with one click. It's also very dangerous if you're running a production, so if you're using this in production, we highly recommend that you don't have flush enabled. And that's it. So Couchbase is configured. So the next thing we want to do to be able to use any of the nickel functionality from our query node is we have to have a primary index to be able to consume and run queries and be able to walk through our documents after we've created them. So the way to do that is we'll use the query workbench here. I'll go ahead and clear the history of that, and I'll just create a primary index. So create primary index, and we'll call it P1, and we'll create that on the comply bucket that we just created. One of the things here that I should mention really quickly is the backticks are the literal escape within Nickel. So if you're new to Nickel and you've not used our SQL variant before, be aware of that. Backticks allow you to escape literal values. And they're also useful for things to denote like a database name. It's not where it's not always necessary, but if you get in the habit of doing that, if you start including dashes and weird characters within names, it allows you to escape those. So definitely get in the habit of doing that if you're not used to that already. And go ahead and execute. We'll see the status is executing and success. So we should have a primary index and ready to go. And next thing we'll do is I'll show what the application looks like when it's running, and we'll walk through how some of these things are working under the covers and what it's doing specific to TypeScript and Angular 2. So first thing we'll do is let's build our app. So if we do, let's see here, so we'll do go build, and then at the same time we want to run it. So we'll do so we'll see immediately once that runs, the first thing it does is it checks to see if there's a default company within the bucket. If there's not, it goes and creates one right away. The reason for that is when we walk through registration in the application, it needs a default company in order to function. So I'll show what this does. So if we go over here, and again, this is the front end Angular application that's talking to the REST endpoints that we have defined within the app under the covers. And I'll go ahead and register a new user. So, and what I was referring to before, this is why we need to have that in order to populate this to be able to pick a company to have a default. So call me Stein, put an address in there. Let's see, say, and Todd at Couchbase.com, Todd. And now if we click save, it immediately created that user for us and brought us into the homepage of the project, which is the projects page. One of the things that I want to do here before I actually create a project, I'm going to use some scripts that I wrote for unit tests for issuing curl commands. And go ahead and bring this up. Don't worry about memorizing what's on here. This is all checked into our repository. So if you're following along, don't feel the need to have to do this. This is just for the sake of this particular this instance of the webinar. We want to show how, with a bunch of users created, and how this functionality works. So what I'm going to do is I'm going to create a bunch of users, two, and I'm going to create 2 additional companies. So I have those to access from within the application. So I'm going to go to my command line. Go ahead and issue these. And so now if we refresh and I go over here to companies, we should see 2 additional companies other than Couchbase, Fox Corp and Test Corp. And when I go and have a project, we should now see 2 projects listed on here. One that's a new project for me, and obviously the one that I own. So it's the same project, it's just showing projects that I own and that I'm part of. So the first thing I'm going to do is from within here is I'm going to create a new task. And before I do that, I want to add some users to this particular project. So one of the users that I created was Ian. So I'm going to add Ian at and so now we see Ian listed there. And I'm going to create a new task. New task for Ian to do. Description for Ian's task. And I'm going to assign that to Ian. Save. So now we'll see that listed here. And what I want to do is show how this works to be able to look and see if a task is assigned to a certain individual. So if I log out of this, and we'll basically clear out whatever local storage I have there by logging out, and I'll log in as Ian. Ian at Couchbase.com, password, and sign in. And now you'll see here tasks I'm assigned to, and new task for Ian to do, and projects I'm a part of, Todd's new test project. So it has the project that I'm a member of as Ian, and that the task that I'm assigned, but nothing under I own. And let's look at what that's doing under the covers and how this works behind the scenes in Couchbase with the specific query as well. So I'm going to fire up Atom, my new favorite IDE. I've been using this for a while now, and it's a great tool. If you're not familiar with it, download it, check it out. The plugins especially give you some really neat stuff to be able to do syntax highlighting and code completion, all the things that you would normally pay a lot of money for a really expensive IDE to do this. The folks at Atom, what they've put out and the community support for it has been excellent. So I highly recommend checking this out. So the first thing we're going to do, let's look at how this front end application is served out again. So I'm going to go to the root file that runs everything. So from within our file, within package main here, you'll see import, etc. Everything that's all the specific packages that we're using within the application. Within this actual file, we have the main func. So if we go down and take a look at this, everything from within our application starts and runs here. So we have the cluster instance that we've defined, we have the bucket that we define as well, and then we have the default company where we check to add that and make sure that it's in there, and then we use Gorilla and create an HTTP router for muxing. And After we've created the router, we have all these routes that we've defined below. And the one that's interesting here that I want to talk about is this one, these two here, at lines 406 and 407. What's unique and interesting about these are, and 408 and 409, we create a prefix that if we see anything that comes in just at the root level, we're going to point it to the public source directory, which, since this is on my same development environment and machine, that's this particular directory here that's served out as a static hard-coded directory. And the same thing for node modules. And we'll go over why that needs to happen in a moment. The main reason is that all of our Angular files and JavaScript files that we need to consume for our application are in this particular directory. And if you're using this as a if you're thinking, wait a minute, why do I see things related to Node.js here, and we're talking about a Go application? The reason is we use npm to install Angular 2 to handle all the dependencies and package management. It's much easier than trying to do that some other way or do it manually. So within the public source directory, if we go over and take a look at that, we'll see here on the left-hand side, we'll see that we have our application that's listed here under app. And the very first thing that'll run, if we look at index HTML, which is, if we go back here, which is in the root. So this will automatically be served out from when Gorilla sees that route coming in for that basically has no URL after the default URL. It will basically send here, and this is where our app runs from. And we'll see here that we do all of the Angular files and how they're run, all of the JavaScript files behind the scenes. And you'll see if there was an issue where it has to actually load those first, you'll see loading until it loads. And then we also run jQuery, we use Bootstrap, and emulation warnings. The main reason we use jQuery that you'll see listed here is for the modals. We didn't find a good solution for how to build modals in Angular 2 yet. That doesn't mean there's not one out there. We just didn't find it in time for when we built this application. So let's walk through the routes that we saw and how these particular how these routes are being consumed behind the scenes and what's being issued. So within our app file, you'll see the main forms, how things are listed. Since this is a single page application, we actually use the app router, and we'll show where that gets instantiated here. If we take a look at the app TS, you'll see that we use router config, HTTP providers, etc. We import all of these specific things to use from within our application. And since we use the Angular 2 router, if we go down and see, our route configs are all listed here. So if there's a default, we immediately go to projects, which is this page here. And when we do that, let's take a look at how the routing works. So when something comes in, first thing it does is Angular, using the app router, checks for that, and then it routes to this specific component. So let's go over and take a look at projects. So within projects, if we go to our TypeScript file, take a look at this, you'll see that we have the component view, we have all of the core things that we're using from Angular in addition to the router, and then you'll see here one thing that we have here is Auth Manager. And then also we have specific interfaces, the iProject, iTask, and iUser that we're consuming from our interface class. And then also we have this nice utility class that we'll go over in a second and how we consume that. So the first thing to do, since we do use Auth Manager, is we want to check and make sure that we're authorized. So what we do is when we construct our constructor for this particular component, it looks at the Auth Manager, and if we're not authenticated, it automatically will reroute to the auth page, to the front page where we logged in. So it's a nice little convenience function to have this in here. If you're building this in something that uses OAuth or a more secure type of topology that you would obviously want to use in production, this is not the way that you would do this. This is just simplified for development purposes. You can still gate things in a similar manner, but you definitely want to pay more attention to security. And also, we're storing things in plain text here and passwords, etc. And you probably, that's something you definitely do not want to do if you're running this in production. So after we've constructed this, we'll see that we instantiate these particular instances of classes from within TypeScript that we're using. And then we get projects. So we make a request, we get all projects that are available, we get other projects, that we list here. So get other, we can take a look at that in a moment and how that's running behind the scenes. And then the one I want to focus on now is this one here where we have tasks I'm assigned to, where we'll see new task for Ian. So remember when we assigned a task to a specific individual and we look at that, this is task that I'm assigned to. And what this does is it uses our utility class. It does a get request and passes in this particular information. It's our auth token, which in this case is just our email address we're using in this particular instance. And when the results come back, we get an array of the interface type tasks. And then once we build that, is we start with a blank array of assigned tasks, and then we iterate through those and populate this to use in the front end. So if we go over and take a look at what that's doing on the HTML side, you'll see where this is tasks and number of assigned tasks. We use ng4 here that allows us to iterate through those, and we basically build this and we consume, if you see here, if you're used to using Bootstrap, this is probably familiar to you, where we've got a row and then we've got a column and panels, and we build these panels at real time based on what's included within the number of tasks within our assigned tasks. So what that's doing behind the scenes, again, let's take a look at this utility class really quickly. Let's take a look at the TypeScript version. And again, one thing I'll touch on, which we talked about last time, is whatever editor you're using, Atom or IntelliJ, whatever it is that you're using, it's great that you can set up a tsconfig.json, which you'll see that listed here on the left, and you can target what you want it to build to based on this configuration. So you don't ever have to compile down to JavaScript. Since TypeScript is a subset of JavaScript, it allows you to compile this as you're building it, so you don't have to worry about compiling it when you try to run it. And in this case, I'm using ES5, so I don't have fat arrow functions and all the cool stuff from ES6 in here, but it's fine for the sake of this application. So again, we'll go back to this our utility TS class, and we'll see here where I do my make get request. And one of the things that's neat about this is I print out some debug information. Again, this is something that you wouldn't want to do in production, but it's great when you're trying to debug and build this stuff in real time. And the reason is if I take a look my dev console in the back end here, and I go over to the console output, you'll see all of the particular outputs that are coming back in, and it makes it great for being able to debug these things. I know, as we always joke, printf debugging is not is not the best way to debug applications, but when you've got a distributed application that's using multiple components across multiple systems, this is an okay way to debug RESTful things in real time. And you'll see, for example, project get other, and the one that we want to really look at is here get assigned to, and we'll see that this really neat array that happens behind the scenes comes back to us, and this is all has nested things within it, including history, including additional users that are part of that particular task as well. And this allows us to navigate through these in real time and also have an entity relationship between these particular documents that's meaningful and be able to consume those in real time. One of the things that we do that's pretty neat, and the reason that we have this embedding in here and this cross-referencing is within our original app that we built this using Node, we have an ODM for Node that we refer to as Ottoman, and Ottoman does a lot of this heavy lifting for you behind the scenes. But we can also mimic that very same type of functionality with Nickel, and we'll get to that in just a moment. But I just wanted to show what this looks like, being able to debug these in real time. So if we go back to Atom here and we take a look, so we basically are making a GET request, and we pass the parameters, we pass the full list of parameters and debug that out into our front-end application, and then once we get a response, we pass that back. So nothing super fancy there other than it's using a promise to subscribe and wait for the success or if there's an error. So pretty easy and pretty cool. It's a great way to build a utility function that you're going to use over and over again. And again, this is all checked in the repos that you can download and take a look at this at any time you want. So then if we go over and we take a look at the particular route that we called. So if we go back to our project TS class and we take a look at get assigned to, API task get assigned to, we'll go over and take a look at our task.go file, and we'll see we have where we retrieve a specific task, and the one that I want to look at is get assigned to. Create, retrieve assigned to a particular user. So this is the function that gets called, and the way that this gets called from that endpoint that we had listed in the front is if we run over to back to our comply go file and we take a look at the route that we have listed in here. So that particular task route was API task get assigned to, and then we have a user ID as a route variable here. And this is one of my favorite things about using Gorilla is it allows you to build route variables like this that are very, very easy. This is kind of difficult without something like Gorilla, and you spend a lot of time writing this code. It's much easier to just use a package like Gorilla that's done this heavy lifting for you. And what this does is goes to the retrieve task assign user handler, and if we go up and find that, this is the handler here, and what all this function does is it creates our variables here are listed into an array. Actually, it's an array interface variable that we build by default when we grab those variables that came in as a route variable from the MUX. We have a session task, which is an object that we use that allows us, or not an object, sorry, it's a type that we use that has several it has several method handlers in there to allow us to consume these things without having to refer to them directly. And we'll talk about that in just a moment. We'll go over to what session task looks like. And then we basically consume that by doing tasks that are retrieve assigned to user, and we pass that user ID in from our variables collection that we grabbed here. And based on this, if there's an error, we return 401. If there's not, we set the header and we write it, and then we send it back. We basically convert the bytes and write the bytes out. Nothing super fancy there, but let's go and again take a look at what this is doing on the other side in the task.go file. So what this does is, again, we have this session task struct that has a method receiver on it that allows us to call this particular function from an instance of a session task that we've created. And session's probably an overloaded term here to use, but it's a great sort of it's a signifier in this example, or it signifies that it's just a instance of a particular task or a task variable that we're using within the application. So based on that user ID that we passed in, and then you'll see here for our return values, we're going to return an array of interface variables, and otherwise an error at the same time. So if there's an error, we'll return that, and then this will be nil. And if there's no error, then we'll return nil. So what we do is we set up a nickel query here, and the reason we do this and that we return this here, this is one of my favorite things about using Couchbase and using nickel with Go, is if I have to strongly type this out specifically, it's going to be a very, very difficult, and I'm going to have a lot of corner cases. And if we take a look at, for example, our session task, if we go up to the top and take a look at this, we've got our task struct here, which there's an instance of within our session task. This maps fairly closely and nicely to what our front-end application is expecting, but it maps directly to what we're storing within Couchbase. And the problem is, in order to be able to consume this, if there's things that aren't present here, having to special case those, or if I need to build things on the fly, it's very difficult to cover all those corner cases. So the way that we do that instead is we actually use a nickel query and return it back as an interface. So I don't really do a lot of processing here. I rely on Couchbase to do that from the nickel interface, and we'll talk about how that works here. So when I retrieve and assign tasks that are assigned to a user, this looks like a pretty ugly, nasty query. So what it's actually doing behind the scenes is very clever, and it's doing a lot of that JSON parsing and building this really rich object that I'm going to be able to consume. So I issue this query, and what I do here is I have this array of interfaces for parameters, and I append my query, where you'll see we've listed the GoCB nickel query here, which is our type of query. I'll append that with the user ID that I'm passing in here, which is, you'll see at line 153 is one of the function variables. And what I do is I issue the query, and I issue it with my parameters, and if there's no error, or if there is an error, I return nil for what's coming back, and I return the specific error. Otherwise, what I do is I iterate through the instance of what I return back, and I basically build this object that I want to return back to my front-end application. And once that's done, I return it back, and I return nil for errors. And one of the things here that's interesting to note is you actually pass the reference to this particular interface object that we built here, and then I'm appending that from when we issued the query. You'll see here that you'll row, and this happens when we actually issued the query, where you see rows, bucket, etc. For rows.next, the reason we do that is this is actually a streaming interface for Nickel. So these results, it's not going to wait to have everything populated and then send it back. It will send results back as soon as it starts receiving them. This is very useful in very large queries and in distributed environments and things where you don't want things to run synchronously, and you don't want them to act synchronously even when they're issued asynchronously. You want things to act also asynchronously. So this is a great way to do this. And again, we pass in a reference to this particular row that we've created here, and we keep appending as we've grabbed the particular value when it comes back into the row, and we just keep appending that into this particular interface array of interface variables that we're going to send back to the front-end application. So once we do that, we come back, you'll see that we sent these back in, and if we look at this behind the scenes from our front-end app, when that came back, is if we'll go back over here and take a look. When we did get assigned to, you'll see Ian@couchbase.com. That was our route variable passed. And then here's the response, Ian@couchbase.com. And here's our array. And again, we kind of talked about this a moment ago. Let's see how this looks and what this does from within Nickel and the query that's actually getting issued. And a great way to do that is once you've installed Couchbase, this UI, again, which is part of the product, you don't have to install anything special to make this work other than Couchbase itself. So I'm going to go ahead and log in. I don't want to say my password. You'll see that we have this query tab, and if I run over here back to the query tab, this is where we created our primary index. We can actually take a look at this query that I ran here and see what it's doing behind the scenes. And I have a version of this that isn't in this particular string, multi-line string version, so it makes it easier to see. So let me grab that real quick. So let's take a look at this. And run over to here. And we'll see here that I've put this in, and in this particular example, make sure that we want to, we're looking at Ian. So let's go back here, and if we go ahead and issue this, you'll see this object, which comes back, it matches exactly what we want, what our front end is expecting. And there's a lot going on here that looks really complex, but when you start getting into Nickel, the learning curve for this is really shallow, and it's much faster than trying to parse and build dynamic front-end structs that or back-end structs that you're going to try and pass to the front end. Some of the things that I'll mention here, we won't go spend too much time in this because that's kind of beyond the scope of what this webinar is, but I just want to go over just a couple things in here. So you'll see that within this, where we have select ID, and then you'll see we have a sub-select for the next value, and then you'll see the brackets here, 0. This allows me to treat any particular value that comes back out of any particular field that I issue in Nickel as an array. So I can say I only want the first instance of this particular thing that comes back. That's very useful when you're doing array type operations. And then also you'll see where I've escaped password. As password's a keyword in Nickel, and our little query workbench here is great about identifying in a different color things that are keywords in Nickel. I would need to escape those. So you'll see that I escaped that. And then also one of the things that I do here at the bottom that I want to touch on is where I do c.assignTo. And this is where I refer to the comply bucket that I've created as C, and then it allows me to interrogate any field in that particular bucket as this way, as like dot field. And you'll see where I've done that here as well. I've done that here, and one of the things that I do here is I use this use keys value. This is one of the most powerful features that we have in Nickel, in my opinion. And it's also an excellent convenience function because it allows you to say, okay, for a particular key that I'm getting back, I want you to, for a particular value in a root of the query, I want you to actually take that and I want you to use the key, and if it maps to some other key within that particular bucket, I want you to be able to resolve that, and then I want you to be able to get those particular values. And that's exactly how we grab this particular ID type from a particular user from assignTo. So when we use that use keys and the assignTo field in Nickel, and again, since that's an array, we'll go and look at the document here in just a second, I'm going to use the first instance of that particular thing that comes back, and I want it to resolve to all of these values. So if we look at assignTo, and we look at in, so let's go ahead and take a look at what one of these documents will look like, which allows us to see what we're assigned to. So in this example, first thing we'll see is this is the particular task that's assigned to in that comes back. So let's go ahead and take a look at that within the bucket. So if I go to data buckets and I go to document, here it is. It's conveniently our first document, and I'll go ahead and grab that. And again, as long as the document that you want to look at is not binary, as long as it's JSON, and as long as it's, I think the limit on this is 2K, you can actually look at it from within Couchbase, within the UI. And this is really useful when you're debugging and building things at runtime. And so we'll see here where it's got users, Todd, and what's important about this is where it's assigned to. You'll see that it's assigned to ian@couchbase.com. So the fact that it's assigned to there, so when I say use keys and assign to, it allows me to resolve this particular value in my subquery. So if we go back and take a look at that, that's exactly what I'm doing here. So I'm using this key, see, assigned to, and as long as there's a key that's ian@couchbase.com, I can grab all of these particular fields about this and return it at runtime. So, and we can verify that that does in fact exist. If we go and we look at in, there's our key. So then if I look at this, we have all of these values in here. And again, I can, these are nested, and when I return it back, this can be nested several levels deep. It doesn't matter. I'm still able to interrogate and use that from within the application. So again, I just wanted to go over brief on how this works. And one last thing that we'll do here is let's take a look at what this is doing for the return in TypeScript again. So after I've issued that particular issued that particular query against the backend system, if we go back over to projects and we take a look at the tasks that are assigned to, again, this is a very simple function that gets called. All it's doing is passing in the auth token, which is the username, and then the result comes back for an array of type tasks. So if we take a look at where that's defined, we can take a look at a task interface here real quick. Let's see where I have the interface. So if we take a look at task, this is what we're expecting back. And it's very useful to be able to do that, and we'll see that the users is an array of type. It's an object type, and if you type this as object for it, it's kind of a hack or a workaround for having things that are strongly typed, which is the whole nature of using TypeScript, is that you're using things that are strongly typed, but it allows you to use something in a more generic format here as an object rather than having to have that strongly typed. So this gives us a little bit of flexibility here in what comes back as an array and also as history. Of course, those are typed. That we do have a type that matches those as well, but for this particular example, it allows us to have a little bit of flexibility in how we build this, and if there's a little bit of changes in what comes back, it's not going to break the front-end application. All right, that's all I had to discuss today, and again, please check out the repository and send any feedback that you have along. We'd really like to hear from you, and we've really enjoyed doing these, and we will continue to talk more about Golang and TypeScript and native script actually next week. Thank you very much.